Welcome students, welcome back to the another session. Now you have chemistry by Ravi Shankar sir. So we'll start now. Yeah, Ravi Shankar sir, you can proceed, sir.
Is it audible, Anikesh?
Yes, sir, it's audible, sir.
Yeah, right. Good morning, everybody. Welcome to our Daya program. And today we'll be discussing topic alcohol, phenol ethers, and nitrogen compounds. Okay, that is organic compounds containing nitrogen, where we'll be discussing about both amines as well as diazonium salts. Okay, let us start the session. First, I will give a brief insight into this particular topic. Okay, then we'll take up the questions. In this alcohols are what we have to study. And my dear students, you know that one. Okay, in alcohols, we are having a general formula ROH. So any compound having a general formula ROH, we call it as a alcohols. Okay, and these alcohols can again be classified based on whether the OH group is attached to sp2 carbon atom or sp3 carbon atom. If OH is attached to a sp3 carbon atom, which are the compounds we are having? The aliphatic alcohol belong to this category. The aliphatic alcohol belong to this category. Then we are having allylic alcohol, so they also belong to this category. Then we are having benzylic alcohol or benzyl alcohol, so they also belong to this category. And if you take another group where OH is attached to sp2 carbon atom, so OH belongs to sp2 carbon atom. We are having a phenol. So where OH is attached to sp2 carbon atom, then we have vinylic alcohols. Vinylic alcohols. So these are the compounds where the OH group is attached to sp2 carbon atom. And aliphatic alcohol, allylic alcohol, and benzyl alcohol are the compounds where the OH group is attached to sp3 carbon atom. And if you take an example for aliphatic alcohol, the best example is CH3OH. CH3OH. And if you look at the structural aspect of it, in alcohol, oxygen atom undergoes sp3 hybridization. sp3 hybridization. So the bond angle expected is around 109, but 109 will be there. Slightly there will be less, as you can see in the box. It will be around 108. Sir. It will be around 108. Why? So because there is a lone pair of electron on the oxygen atom, and we already studied, sir, lone pair repulsion is more than bond pair repulsion according to VSE pair theory. So due to the repulsion, the bond angle slightly decreases, sir, slightly decreases. This is one point you have to remember regarding structural aspect. And as you can see, the CO bond length in alcohol is around 142 picometer, whereas OH bond length is 96 picometer. This is the structural aspect of alcohol. And coming to the preparation of alcohols. We can prepare alcohol by treating alkyl halide. You can see RX. By treating alkyl with KOH, a nucleophilic substitution reaction form an alcohol. So you can prepare it from hydrocarbon also. Means you can prepare from alkene. There are two ways you can prepare. Either by Marconi-Kaful, either by anti-Marconi-Kaful. When you add to an alkene, okay, this alkene undergoes acid catalyzed hydration to form a alcohol according to Marconi-Kaful, where you are adding a water. You can see that. In the presence of acid, you are adding a water. So it follows Marconi-Kaful, you can get alcohol. Either you can do hydroboration. Hydroboration means you are adding a borane, B2S6. You are adding a borane. And then you are subjecting it to oxidation. It follows anti-Marconi-Kaful. Then also you get alcohol, but according to the anti-Marconi-Kaful. Other than that, so we can obtain from carbonyl compounds, where aldehyde is subjected to reduction. When aldehyde is reduced, we get primary alcohol. So when ketones are reduced, so we get secondary alcohol. You can use any kind of reducing agent. Either you can use platinum, palladium, nickel, or sodium borohydride, lithium aluminide, or sodium and ethyl alcohol, all those things you can use as a reducing agent. You can use a reducing agent. But for carboxylic acid, we have to use a strong reducing agents, lithium aluminum hydride or diboron we have to use. Then only it undergoes reduction to form alcohol. Very, very important that you remember. Okay. And we can also prepare alcohol by using Grignard reagent. So we can prepare it by using RMGX. How this is possible? Very simple. So if you treat formaldehyde with RMGX, we are going to get primary alcohol. If you use any other aldehyde, so if it is any other aldehyde, it reacts with Grignard reagent to form secondary alcohol. So if it is a ketone, it can react with Grignard reagent, RMGX, to form tertiary alcohol. Okay. We'll go to the next slide. And also physical property. I'll just give you a brief insight into physical property also. So if you look at the physical properties, sir, usually the physical property, two important physical property are there, boiling point and solubility. So is it soluble alcohol? Yes, they're soluble because they form a hydrogen bond with water. But solubility keeps on decreasing with the number of carbon atoms. It is inversely proportional to size. As the number of carbon increases, the solubility of the alcohol also decreases. When it comes to boiling point depends on the number of carbon atom. More the carbon atom, more the boiling point. And it also depends on branching, but it is inversely proportional. Boiling point is inversely proportional to branching. More the branching, less the boiling point. And boiling points are also directly proportional to number of force of attraction. Number of force of attraction, sir. Number of force of attraction. We'll go to chemical property. We will just take it out a little bit about chemical property. I will take a pen from a Zoom. Just give me a minute. Because the Zoom pen is very easy to write, I will take that one. So coming to chemical property. Okay, there are mainly three kinds of reactions. Which are the three kinds of reactions, sir? The reactions involving cleavage of OH bond. The reactions involving cleavage of OH bonds. The reactions involving cleavage of CO bond. Second type of reaction. The third type of reaction which involves the whole alcohol molecule. So these are the three type of reaction what we are having. One by one we will study it. Okay. So first we will take cleavage of OH bond. So what are the reactions are present in this category? The reaction with sodium comes under this heading. The reaction with sodium hydride, yes, comes under this heading. Sir, esterification. Then we are having acetylation. All these things comes under this heading. All these things comes under this heading. Whether reaction with sodium or sodium hydride or formation of ester or acetylation, they all come under this heading. So what about acidity? Among the alcohol, primary alcohol is more acidic in nature than the secondary and tertiary alcohol. So why in tertiary alcohol the acidity decreases? In tertiary alcohol the acidity decreases because if you observe it, in tertiary alcohol there are more alkyl groups are present. And these alkyl groups will decrease the acidic nature. They are electron donating group. So they decrease the acidic nature. Whereas primary alcohol, As only one alkyl group, so the acidic nature when compared to tertiary is more. It's more. First of all, sir, is it a alcohol acidic in nature? Yes, alcohol is acidic in nature. Sir, alcohol is acidic in nature. Yes, it is acidic in nature. How do you know that it is acidic in nature? Because it reacts with sodium. It reacts with sodium. That's why we say it is acidic in nature. It's acidic in nature. And when you take the acidic nature of primary alcohol is more than secondary and tertiary alcohol. Please remember this part. But when compared to phenol, the acidic nature of alcohol is less. In fact, it is lesser than water also. Why we say acidic? Because the ROH can dissociate to form what? RO and H plus. Anybody who gives H plus is acidic in nature. But this RO minus is not very stable. It is a less stable only. So it cannot be a strong acid. It is acidic in nature, but it is not a strong acid. Coming to one more type of reaction where the cleavage of CO bond will take place. They will take the cleavage of CO bond. Here, when the CO bond breaks, for example, if I take a molecule called as RCH2OH, when this CO bond breaks, what I get is RCH2 plus. That means carbon carrying positive charge. There's nothing but carbocation. Then this reaction depends on the stability of a carbocation. So the order of the reactivity is tertiary alcohol is more reactive than secondary and primary alcohol. So what are the reactions in this category? You can take reaction with HCl, comes under this category. Reaction with SOCl2. So reaction with PCl3. Reaction with PCl5. All these reactions comes under the heading cleavage of CO bond. Cleavage of CO bond. Anikesh?
Yes, sir. Yes, sir.
Any doubts are there from students?
No, sir. As of now, no one has.
Somebody has raised the hands. That's why I asking.
No. By mistake, he raised and he lowered.
Yeah, right. No problem.
Yes, sir.
Then, so what are the reactions involving whole alcohol molecules? Whole alcohol. So, my dear students, be clear. When there is a cleavage of OH bond, primary alcohol is more reactive than secondary and tertiary. When there is a cleavage of CO bond, tertiary alcohol is more reactive than secondary and primary. But you should remember, what are the reactions? In the cleavage of OH bond, reaction with sodium will come, reaction with sodium hydride will come, esterification will come, and acetylation will come. All these reactions will come under this heading. When there is a cleavage of CO bond, which are the reaction? I told you reaction with HCl, Lucas test, PCl3, reaction with PCl5, reaction with thionyl chloride. All this comes under this heading. Then we'll go to reactions involving alcohol molecule, whole alcohol molecule. What are the reactions? So dehydration. Dehydration is nothing but removal of water. Again, when you remove the OH group, what you get is carbocation. Again, the reaction depends on the stability of the carbocation. And here, the usual dehydrating agent what is used is sulfuric acid. And alcohol undergoes dehydration. When the alcohol undergoes dehydration, it can form three kinds of product. At 443, it can form alkene. At 413, it can form ether. At 383, it can form alkyl hydrogen sulfate. Very, very important. Then you can use alumina also. Alcohol can undergo dehydration with alumina also at 513 Kelvin to form ether, at 633 to form alkene again. And these two reactions are very, very important. Formation of alkene and ether. Frequently, they're asking in examination. I'll show you one reaction. What happens when alcohol undergoes dehydration? Let me take a board. I'll write it here. So let us take one alcohol. Example, CH3CH2OH. So ethanol. It reacts with sulfuric acid. Let us write sulfuric acid as a HHSO4 rather than writing H2SO4. What will happen? So the OH will combine with H to form water. This undergoes dehydration. Dehydration. What do we get? So then we get CH3CH2, that is ethyl. And you are having hydrogen. So ethyl hydrogen sulfate, we get it. And this ethyl hydrogen sulfate again undergoes reaction at what temperature? Let us say at 443 Kelvin. At 443 Kelvin. What will happen, sir? This ethyl group loses one hydrogen and that combines with HSO4 to form sulfuric acid. So what is remaining then? Sir, in that CH3, one hydrogen is gone, so CH2 is there. And here also we are having CH2. Valency of carbon is 4, so you get double bond. What is this? Sir, alkene. So we get ethene. When you heat the alcohol, our alcohol is subjected to dehydration at 443 Kelvin, so we end up eating alkene. Very, very important this is. Next one, I clear all these things. So what is oxidation? Addition of oxygen. When the, I'll take the pen. When the alcohol undergoes oxidation, it forms aldehyde. When further undergoes oxidation, it forms carboxylic acids. Carboxylic acids. But there is a small difference. I'll just tell you how it is. Again, I'll take one board here. Let me take a small chalk piece. So let us take oxidation. What will happen, sir, when alcohols undergo oxidation? When an alcohol undergoes oxidation, usually they form aldehydes or ketones. And then further they form what? Carboxylic acid. This happens only with the strong oxidizing agent. So this happens only with the strong oxidation. And if you take a primary alcohol, if the alcohol is primary, then sir, after oxidation, we not get ketone, but we get aldehydes. When aldehyde undergoes oxidation, then you get a carboxylic acid having a same number of carbon atom. So you'll be having a same number of carbon atom. What do you mean by that? That means in a primary alcohol, if you're having, say, 3 carbon atom, then your carboxylic acid will also be having 3 carbon atom. If a alcohol, secondary alcohol undergoes oxidation, so then we get ketone, sir. We don't get aldehyde, we get ketone. When ketone undergoes oxidation, we get a carboxylic acid having a less carbon atom, sir. A less carbon atom. Always remember this one. So primary alcohol gives you aldehyde, secondary alcohol gives you ketone. Sir, dehydrogenation. What is dehydrogenation? Sir, removal of hydrogen. Sir, removal of hydrogen. When you remove hydrogen, primary alcohol gives you aldehyde, secondary alcohol gives you ketone. And the reaction condition is copper metal at 273 Kelvin. Very, very important. This is. So what is dehydration? When the tertiary alcohol undergoes dehydration, because tertiary alcohol do not undergoes dehydrogenation. It undergoes dehydration with the same catalyst and copper to form an alkene. It will not form another molecule, it forms an alkene because it cannot undergo dehydrogenation. It is not possible. So it undergoes dehydration, losing water molecule forms an alkene. So all this reaction, whether it is a dehydration, oxidation, or dehydrogenation, it is due to whole alcohol molecule. So remember, my friends, there are 3 kinds of reaction: cleavage of OH bond, cleavage of COO bond, and reaction due to whole alcohol. Yes, thank you.
Sir, Miss Purnima is asking, sir, can you repeat third point once again?
Yeah, right. You please allow Purnima to speak. No problem. I'll speak to her.
Okay.
Yeah, Purnima, tell me, what is the doubt you are having?
Yeah, Purnima, I've allowed you to speak. You can unmute yourself.
Sir, if we add dilute H2SO4, what we obtain, sir?
Here, what will happen? No, say for example, this alcohol, there are two things. If you take dilute sulfuric acid, I already told you, when you add a dilute sulfuric acid, they undergo hydration. And if you take constant sulfuric acid, they undergoes dehydration. And for dehydration, there's no rules that you have to take sulfuric acid only. You can take alumina also. Even alumina can act as a dehydrating agent. Not only alumina, you can also use P2O5, phosphorus pentoxide. It also acts as a dehydrating agent. Got it, Purnima?
Yes, sir.
Okay, thank you then. Then, so let us few tests for alcohols also. Which are the tests, sir? Which are the tests we are having? So we are having dichromate test. So primary alcohol, if you take, when you do dichromate test, I told you acid with the same number of carbon you get. Whereas secondary alcohol gives you ketone with the less number of carbon atom. It is not same. Here there is a, we have to write, sir, less number of carbon atom. So tertiary alcohol, no reaction. So primary alcohol gives you aldehyde. Secondary alcohol gives you ketone with a less number of carbon. Tertiary alcohol, so no reaction. This is one test. One more is Victor-Mayer test. In Victor-Mayer test, primary alcohol, you know that one, it gives a blood red color, whereas secondary alcohol gives blue color, whereas tertiary alcohol, colorless. Come to Lucas test. What is Lucas test? Where we are using Lucas reagent. You know Lucas reagent. What is Lucas reagent? Sir, SCl and anhydrous zinc chloride. Anhydrous zinc chloride. When you add this reagent to the alcohol, tertiary alcohol gives turbidity immediately, whereas secondary alcohol gives after 5 minutes. In a primary alcohol, at room temperature, there is no turbidity. You get turbidity only after heating. So at room temperature, there is no turbidity for primary alcohol. We know that tertiary alcohol is more reactive in this case. Why? Because the reaction with HCl comes under the end cleavage of CO bond. And which alcohol is more reactive? Tertiary alcohol is more reactive, sir. Please remember these things. Then, little bit about methanol and ethanol. Methanol is also called as we call it as a wood spirit because it is obtained by fermentation of a wood, which is a long process. But nowadays, in a commercial way, we prepare it in a very few minutes only by taking water gas, by heating with that zinc oxide and chromium oxide. We can get methanol instantaneously. Then coming to, and methanol is used as a solvent and preservative and a substitute for petrol. But remember, it is poisonous. Methanol is a poisonous. And most of our alcoholic beverages, what people use, no, beer, brandy, wine, all these alcoholic beverages we call it as. Sir, alcoholic beverages are made up of ethyl alcohol. Ethyl alcohol.
Sir, Pratham
And
wants to ask some questions, sir.
yeah, tell me.
Yeah, Pratham.
Sir, what is the reagent in Victor Meyer's test, sir?
Which one?
In Victor Meyer's test.
Yeah, I'll come to it. I'll just finish it and I'll come back. Okay.
Okay, thank you, sir.
All right. So coming to this one. So most of these alcoholic beverages they're made up of what? So they're made up of ethyl alcohol only. What is ethyl alcohol? C2H5OH. So ethanol, And there are so many terminology involved in it. I'll just explain to that and I'll go to this Pratham question. Let me take a board first. Let me take a board. Yes. I will take a board on this side. Take one small chalk piece. What is meant by, sir, absolute alcohol? What is meant by absolute alcohol? The 100% ethyl alcohol, if you obtain, we call it as a absolute alcohol, sir. So what is meant by rectified spirit? What is meant by rectified spirit? So what is meant by rectified spirit? Sir, 95.5% alcohol. Alcohol. Plus 4.5% water, we call it as a rectified spirit. Rectified spirit. So what is meant by denatured alcohol? What is meant by denatured alcohol? Most of the commercially available alcohol. What is the commercially available alcohol? The alcohol available in the lab. The alcohol available in the lab, we call it as a commercial alcohol. And most of this commercial alcohol was misused by people. And this commercial available alcohol is available for a very lower price. And it was a loss for government. So what government has done to prevent the loss of the revenue for a government? So government, what it has done is that they denatured the commercially available alcohol. So what we can call it as commercially available alcohol. So commercially available alcohol is made unfit. What is commercially available alcohol? Alcohol present in the laboratory, present in the industry, all those things. We call it as a commercially available alcohol. This commercially available alcohol is made unfit for drinking purpose. Is made unfit for drinking purpose. Is made unfit for drinking purpose. Purpose. By adding, what we add? So we add copper sulfate to give a bad color. We add pyridine to give a very bad smell. To give a bad smell. And also we add a little bit of methanol because we know that methanol is a poisonous. And by adding all this chemical, the government has made commercially available alcohol unfit for drinking purpose. And this is known as denatured alcohol. Denatured alcohol. Take one screenshot. Just you have to know a little bit about this methanol and ethanol also. And ethanol. And ethanol can be obtained by fermentation of that. There are two ways you can obtain it. Either you can get it from molasses. Molasses is the waste obtained after crystallization of sugar. What we have to do to this molasses, we have to add yeast. The fermentation will start. And when the fermentation starts, the yeast secretes two enzymes. One is invertase and zymase. And these two enzymes converts the alcohol, converts the sucrose into ethyl alcohol. There's one more method is there. We can also obtain it from starch. Again, by same method, fermentation. Okay? But here, first what we have to do is that, first we have to add enzyme called as diastase. And this enzyme converts the starch into maltose. And then we have to add enzyme called as maltase. They convert it into glucose. Then glucose is converted into ethyl alcohol, C2H5, OH, C2H5, OH. This is what we have to do. Okay, so this much we have to understand word. Then we'll come to that question. Somebody has asked it, sir, what is a Victor-Mayer method? I already told you. In Victor-Mayer method, primary alcohol gives you blood red color. Secondary alcohol gives you blue color. Tertiary alcohol gives you colorless. So what is the reagent we are adding here? I will take a board. So what is the reagent we are adding? I will take a one white chalk piece. So to give an alcohol, what you have to add? First, you have to add iodine in terms of phosphorus and iodine. Then you have to add AgNO2, silver nitrate, AgNO2. Then you have to add HNO2. These are the reagents what you have to add. If your alcohol is primary, then it forms a compound called as nitric acid. And nitric acid is blood red color. If your alcohol is secondary, when you add these reagents, iodine, AgNO2 and HNO2, you'll end up getting a blue color. Due to formation of a pseudo-nitrile, which is in a basic solution, gives you, sir, blue color. Whereas in tertiary alcohol, there is no reaction. So there is no reaction, sir. So we call it as a colorless. Got it? This is about Victor-Mayer method. Now we'll go to phenols. Sir, how to prepare a phenol? You can prepare a phenol by using benzene sulfonic acid. So we can prepare it by benzene sulfonic acid by treating with NaOH and then further hydrolysis by HCl. So we can prepare phenol by using benzene diazonium chloride. So we can prepare phenol by using chlorobenzene, a nucleophilic substitution reaction at high temperature and pressure. So we can prepare phenol by using cumin. Very, very important. Cumin is also called as isopropyl benzene. In a two steps. First by oxidation and then by hydrolysis. And phenols are colorless liquids and solids. Yes, they're slightly soluble in water because they form a intermolecular hydrogen bond. They form a hydrogen bond with water, so they're soluble. Both alcohol and phenols are soluble, but alcohols are completely soluble. Phenols are slightly soluble. Remember this one. So what are the important reactions of this particular phenol? Very, very important aspect of phenol is acidic nature. I'll take a board and I'll explain to you. Which board we'll take? We'll take brown board. Very, very important property of phenols. What is the property? The acidic nature of property. Is that phenol acidic? Yes, phenol is acidic. Yes. Why? Because it reacts with sodium. Anybody who reacts with sodium is called as acidic. Yes, sir, it is acidic. Is it a phenol a strong acid or a weak acid? Or a phenol, is it an acid, first of all? Is it an acid? Yes, sir, phenol is an acid. What kind of acid? Say it is a Lowry-Bronsted acid. What is a Bronsted acid? One who donates a proton. One who donates H+. Yes, sir, it is an acid because it donates H+. And it is acid because it reacts with base. It reacts with base like NaOH. Hence, these two reactions shows that phenol is acid. And by donating H+, in fact, phenol can form a stable phenoxide ion. Equilibrium will shift to right side only. By donating a H+, they can form a stable phenoxide ion. And this phenoxide ion is more stable than the phenol itself.
So there are some questions, sir.
Yeah, right.
Sir, may Uttar Pratham is asking, sir, which is more acidic, phenol or phenoxide ion?
Okay. Here, phenoxide is more stable. In fact, phenoxide is more stable than phenol. Phenol. And phenol is acidic. Phenol is acidic because it donates H plus. So phenoxide is not as acidic. Phenoxide is not acidic. We can say phenoxide ion is more stable than the phenol itself. Why phenoxide is more stable? Pratham, you can say like this. Why phenoxide is more stable is phenoxide is more stable than phenol. Why is more stable than phenol? You can say, sir, here there is a distribution of charges in a resonance structure. So there is a distribution of charge. So here there is a separation of charge. When there is a separation of charge, you need more energy. When there is a separation of charge, you need more energy. When there is a distribution of charge, you need less energy. And in chemistry, one who is having less energy is more stable. More stable. Pratham, you got it? Anikesh, ask him. Or put him on the speaker. Anikesh, Pratham, are you there? Pratham, you can put it in chat box also.
Yes, sir, I got it, sir. Thank you.
Okay, right.
So there's one more question.
Yeah.
Sir, difference between inter and intramolecular bonds.
Yes. I will tell you one thing. I'll explain to you here one week. I will take one more board. Or I will take it from here. This I want it. I will take it from here. What is the intramolecular and intermolecular hydrogen bonds are? For example, this alcohol, they are having an intermolecular hydrogen bond. I should take this one. See, you're having things like this. ROH. And this, what will happen is that this molecule, hydrogen, it forms a intermolecular hydrogen between the alcohol. This is called as inter. What is intra, sir? Intra is like this. Say, for example, I will take orthonitrophenol. Orthonitrophenol, sir. This is NO2. And there will be one OH here. And here, between the oxygen and the hydrogen, there is a bond. So this bond is within the molecule. This bond is within the molecule. This is called as, sir, intramolecular hydrogen bond. This bond is between two molecules. So this is called as intermolecular hydrogen. Ask Anikesh whether it's got it or not.
Yeah, sir, he has not written his name.
Yeah, okay, right. We'll move on to next one. So I will again now take out this word because I read up this board. Coming to acidic nature of phenol, very, very important topic this is. So phenol is an acid and it is also acidic. So is it a strong acid or weak acid? Phenol is a weak acid. Remember this one. It's not a strong acid. It's a weak acid. So it's a weak acid. And usually weak acids are measured by the Ka values. What is Ka? Dissociation constant of acids are. If Ka is more, that means stronger acid. So if Ka is less, that means acidic nature is less acidic. Less acidic. Very, very important. This is. Sometimes it is also given in terms of pK. What is pK? It's called as negative log of Ka. So the values become inverted. Means if pK is less, that means stronger molecule. Acidic. If pK is more, that means is lesser acidic. is lesser acidic. Lesser acidic. Very, very important this is. And also remember, my dear friends, electron donating group. So electron donating group, like what? Methyl group, sir, methoxy group, OH groups, NH2 group, all these groups, no, they will decrease the acidic nature. They will decrease acidic nature. So electron withdrawing group, like chlorine, bromine, halogens, nitro group, all these groups will in fact increase acidic nature. Will increase acidic nature. Just remember this one. You can take a screenshot. Aldehyde groups, ketone groups, carboxy groups, these will increase acidic nature, sir. We call it as electron withdrawing groups. So this much you should remember in acidic nature of phenol. I'll remove this one. Then what are the other chemical property? ESR reaction. Whenever ESR reaction takes place, what is ESR reaction? Sir, halogenation, bromination, nitration, sulfonations, all these are ESR reactions. Treadle-Craft acylation. Here, what the product we get? Sir, we get ortho and para product we get it, sir. Ortho and para product we get it. Then, even the electrophilic substitution reactions are Cope's reaction. Even Reimer-Tiemann reaction is also electrophilic substitution reaction. I will take a board for it to explain it. So what is a Cope's reaction? Whenever a phenol, sir, reacts with NaOH and carbon dioxide at 6 to 7 atmosphere, it gives a salicylic acid. And this reaction we call it as a Cope's reaction. Remember this one. And salicylic acid, when undergoes acetylation, salicylic acid, what is salicylic acid? OH, COH. When undergoes acetylation, what is acetylation? Addition of an acetyl group. It forms a molecule called as aspirin. What we take it for our headache? OCO-CH3 and COH. We call it as a aspirin. So what is a Reimer-Tiemann reaction? This is also ESR reaction only. When a phenol reacts with chloroform and NaOH, it forms salicylaldehyde. Salicylaldehyde. And this molecule is having an aldehyde. Phenol is having an aldehyde. Is having an aldehyde. This reaction we call it as a Reimer-Tiemann reaction. And very, very important is that here the intermediate is carbene, we call it as a, we get CCl2, we call it as a carbene. Carbene is the intermediate. In fact, that is the electrophile. The carbene itself is the electrophile. And that's why it is called as electrophilic substitution reaction. Here in this reaction, sir, CO2 is the electrophile. CO2 is electrophile. So in chlorination, Cl plus is the electrophile. So in nitration, NO2 plus is the electrophile. So in bromination, Bl2 plus, Br plus is the electrophile. So in sulfonation, SO3 is the electrophile. Neutral electrophile it is called as SO3. So in a Treadle-Craft alkylation, CH3 plus is the electrophile. So in a Treadle-Craft acylation, sir, it's a COCH3 plus is the electrophile. All these are ESR reaction only. In all the ESR reaction, the product what you're getting is ortho and para. Ortho and para. Take a screenshot. I will remove this. And ethers, if you come to this, ethers are having general formula ROR. They can be prepared by Williamson ether synthesis. You know that one. Where alkaloid reacts with sodium alkoxide. And alkaloids should be always, remember, it should be primary. It should be primary. And alcohol reacts with sulfuric acid at 413 Kelvin, undergoes dehydration to form ethers. And Williamson ether synthesis is a SN2 mechanism. Remember this one. And in Williamson ether synthesis, instead of primary, if you take secondary and tertiary, elimination takes place to form alkene. Then coming to physical property. So they are having a slightly polarity due to CO bond. Boiling points are lower than alcohols. Why? Because they don't have hydrogen bond. Whether they're soluble in water? Yes, because they form hydrogen bond with water. But the solubility decreases with increase in molecular mass. They are soluble in organic solvents and they're lighter than water. So what is the other chemical property? Very important. The first one is that, remember, these particular ethers are easily undergoes oxidation in air. These ether easily undergoes oxidation in air when exposed to air to form peroxides, and they're highly explosives, unstable molecule. They can react with acid because the ethers are a Lewis base. They can react with the acid to form a salt. And when come to this ESR reaction, electrophilic substitution reaction, yes, again, they give only ortho and para product. They give ortho and para product. And when you take a cleavage of CO bond, important reaction is reaction with HX. Reaction with HX. When it reacts with PCl5, it forms RCl. When it reacts with water, it forms alcohol. Okay. Whereas in case of reaction with HX, this is very, very important. I will show you the reaction of HX. I will take 3 cases and I will show you. So what happens when this HI reacts with symmetrical ether? What is symmetrical ether? It's like this. CS3O, CS3 plus HI. If it is like this. If it is a symmetrical ether, any one of this bond will break. And what will happen? The I go to one part and the H will go to another part. So you get CS2OH, a methanol, plus you get methyl iodide. If you take an unsymmetrical ether with HI, so what will happen? What is unsymmetrical ether? Let us take C2H5, ethyl, methyl, ethyl we call it as. Plus HI if I take, what will happen? So then I always goes to a smaller part. The H will go to the bigger part. So what you get? The bond breaks with the smaller alkyl group. So you get C2H5OH plus you get CH3I. Then if you take a aromatic ether plus HI, so what will happen? What is aromatic ether? We'll take anisole. So OCH3 plus HI. Then what will happen? The breaking the CO bond is difficult because it is having a partial double bond. So easy to break this CO bond. So the I goes to again the smaller part. So you end up getting what?
Excuse me, sir.
Yeah.
So Mr. Sam is asking, sir, could you please explain the first part again?
Yeah, I'll tell you.
Symmetric ether plus HI.
Yeah. Sam, in a symmetrical ether, it's very simple because both the group on either side of a this one, I will take blue color. Both sets of ether is a CH3 group. I will take a little lighter one. So both are CH3 group only. So both are symmetrical means any bond you can break. You can break any bond. And you get CH3I, CH2OH. Whereas in unsymmetrical ether, the I always goes to the smaller part. I always goes to smaller part. In aromatic ether, the breaking a CO bond attached to benzene is difficult because it is having a double bond. So it goes to CO bond of alkyl group. That means I again goes to the smaller part.
Okay, sir. He got his answer.
Yeah. If it is like this, if your ether is having a tertiary alkyl group, if it is like this, if it is like this I always goes to tertiary carbon atom. So this we call it as a the reactions involving ether having a tertiary alkyl group. Ether having tertiary alkyl group. In this case, all these reactions are SN2 mechanism. But this reaction follows the SN1 path. Then what will happen? You get tertiary butyl iodide. You get tertiary butyl iodide plus you get CH3OH. Okay, this is enough for this alcohol phenol ether. What I'll do is that I have made a chart like this also. You please go through it. Mr. Nikesh will be sharing these slides also. You can make a best use of it. Where entire NCET book, you can just recall in a one sheet. I've done it like that. Okay, this is about phenol, this is about ethers. Okay, next I'll go to questions. So for the sequence of reaction, A reacts with ethyl magnesium iodide to form B. B undergoes hydrolysis to form tertiary pentyl alcohol. The compound A in this sequence is, what is the compound A in this sequence? So how to solve this? Very simple this is, because already we know you got tertiary alcohol here. You got tertiary alcohol here. And we know that when aldehyde reacts with Grignard reagent, you get primary alcohol. When is the case? When it is aldehyde is formaldehyde, you get primary alcohol. When it is any other aldehyde, you get secondary alcohol. When it is a tertiary alcohol, you get tertiary alcohol only when ketone reacts with RMGX. Over. So now you are having tertiary alcohol. So A should be ketone, sir. A should be ketone. Which is the ketone? Let us remove unnecessary answer. B is unnecessary, sir, not related. Over. So what is the answer? Either A or C, sir. And tertiary pentyl alcohol. It is having, name itself says, how many carbon atom it is having? So it is having 5 carbon. And in your Grignard reagent, already how many carbon you are having? 2 carbon. Then A should have 3 carbon, sir. And the ketone having 3 carbon is, sir, answer is acetone. Butane cannot be, because butane is having 4 carbon. If I take butane, I will end up getting 6 carbon. But I'm supposed to get only 5 carbon. So answer should be acetone, sir. What is acetone? CH3, C double bond O, CH3. It is having 3 carbons, sir. That is the answer. You can take a screenshot. Then, how many isomers of C5H11OH will be primary alcohol? Very simple. C5 means how many carbon atom? 1, 2, 3, 4, 5. This is OH. And this is CH2. So this is CH2, CH2. So valency of carbon is 3, 4. So we have to make it CH3. So this is one isomer. It's a primary. Because this alcohol is this carbon is a primary carbon. Let us write one more structure. CH3, CH, CH3, CH2. How many carbon? 4 is over, sir. 5 OH. Yes, you check it out. It is also having the molecular formula C5H11OH. So second isomer. And this is again a primary carbon. Again, this is a primary alcohol. I can write one more CH3, CH2, CH3. 4 carbon is over. 5 carbon and OH. Again, this is also primary carbon, so primary alcohol. I'll write one more. CH3, CCH3, CCH3, CH2OH. And again, this is a primary. So total, how many isomers are there? Sir, 4 isomers are possible. So our option is C.
Sir, can you view the previous slide, sir?
Previous slide, maybe
With
because
solving, sir.
huh?
The previous slide with solving, sir. Question number 1, sir.
Yeah, but it will not be there because this I'm not able to save it. No.
Okay, sir. No students wanted to take screenshots.
I told them to take a screenshot.
Okay.
It will be in recorded things, no? They can take it.
Sakshi, in the recorded session, you can just view it.
Because
and
once I remove it, in my laptop, it is not saved.
Okay, sir. Okay.
Yeah, right.
No issues, sir.
Take a screenshot. Take a screenshot.
Sir.
Next one.
Hello.
Yeah.
Sir, what if we have like 4 carbon in one chain and 1 carbon will be in the extreme end, sir, and OH will be in the other extreme end?
Yeah, you can take it, but if you take other end also, my dear friend, you have to give IUPAC name. What is the IUPAC name?
Yes, sir.
This is 1, this is 2, this is 3, this is 4. No.
Okay.
So what is this molecule? What is the name of this molecule? It's a butanol.
3.
Is it not?
Yeah.
What kind of butanol? This is a 3-methyl butanol.
Yes, sir.
You can write it ulta also. CH2OH, then second carbon, then third carbon, you are having CH3, then CH3. And you do the IUPAC nomenclature, same thing will come. Because the carbon attached to OH will get 1, 2, 3, 4.
Yeah. Got it.
Both are same only. So no need to write this one. One structure is enough.
Okay. Yes, sir.
Okay, I will clear this.
Yes, Varshita, you want to say something? You raised your hand. Varshita. Students, please take screenshot if you want now, or later on you can take it from the recording sessions.
HBr react fastest with which molecule? And I already told you, in alcohol there are 3 kinds of reaction. Where you are breaking a OH bond. When you break a OH bond, which alcohol is more reactive? Primary is more reactive than secondary. Secondary is more reactive than tertiary. When you break RO bond, means CO bond. Tertiary alcohol is more reactive than secondary and primary. So then you have to see, HBr will break which bond? Let us take alcohol, RCH2OH. When it reacts with HBr, which bond will break? It forms RCH2Br. RCH2Br. That means OH is removed. That means CO bond will break. When CO bond breaks, tertiary alcohol is more reactive. So you have to find out tertiary alcohol. B, he says primary, that is, cannot be. D, he says propanol, primary, cannot be. 2-ol, secondary, cannot be. Very simple. Answer is yes, sir. If you want, you check it out. It is tertiary only. So how it is tertiary? Let us write the structure. Propane 2-ol. 1, 2, 3. 2-methyl. Write on 2-methyl. And there is a OH here. And this carbon is a tertiary, sir, because it has to how many carbon atom? Sir, it is attached to 3 carbon atom. So the tertiary alcohol is what you take, and first option is right, sir. Take a screenshot. So propene on hydroboration oxidation produces what? You take it as a propene on hydroboration oxidation produces. What is a propane? Sir, CH3, CH double bond, CH2, no? And I told you, if it is a acid catalyzed hydration, it is a Markovnikov. But this is a hydroboration. What is hydroboration? You are adding a borane, hydroborane. Hydro means BH3. What will happen then? 3 molecules of propene will combine with this to form CH2, CH2, tripropyl borane. And this tripropyl borane, then what will happen? Undergoes oxidation with hydrogen peroxide. And the B will be removed as H3PO3. And in that place, you get OH, CH3, CH2, OH. What is the option, sir? So first option. Next question. Sir, ethanol reacts with PBr3 to form X, which reacts with alcoholic KOH to form Y. Then it undergoes hydration to form Z. So this Z is the ethanol. What is ethanol? CH3CH2OH. When it reacts with PBr3, the OH will be replaced by Br. CH3CH2Br. This undergoes reaction with alcoholic KOH. What is the reaction this is called as? I already told you. Dehydrogenation means you are removing halogen as well as hydrogen. How you remove it? Say K removes Br. It becomes KBr. The OH will remove from next carbon atom hydrogen. So it becomes water. So what do you get? You get CH2 double bond CH2. So what is this molecule? Sir, alkene. So this is Y. So this is Y. And this is X. So what is the next one? This undergoes hydration. What is hydration? Addition of H plus and OH minus. So what will happen? The H plus will attach to 1 carbon. OH will attach to 1 more carbon. What will happen? CH2 becomes CH3 and CH2OH. Oh, same molecule gets repeated. What is the answer? The answer is A. Take a screenshot.
Hello, sir.
Yeah.
Sir, I didn't understood how did you took H plus and OH minus because water
Hydration,
would
no.
come in.
Here he says sulfuric acid at room temperature. There is nothing but dilute sulfuric acid. When he says sulfuric acid, he is not mentioned concentrated. That's a dilute sulfuric acid.
Okay.
Dilute sulfuric acid is always used for hydration.
Yeah. Yes.
It is also called as acid catalyzed hydration. Got it?
Yes, Miss Sahana. Do you have any doubt?
Got it.
Yeah, Sana, tell me.
Sahana, you just raised your hand. Okay. I think by mistake, sir.
Okay, no problem. Say, look at here. Last case CET, they again question like this. Which of the following on heating gives an ether as a major product? Ethane as a major product. We know that ether is obtained by Williamson ether synthesis. Williamson ether synthesis. What is that? Alkyl halide reacts with what? Sir, sodium alkoxide. Reacts with sodium alkoxide to form ether. And we know that, I already told you, alkyl should be always primary. That's the condition. Then just look at the alkyl which is primary. Sir, this is what R. Sir, no, sir, this is a 3. Tertiary, this is tertiary. Then R is ruled out. R cannot be. Then yes, sir, their halogen is attached to double bonded. This is a vinylic halide. S is also ruled out. Then PQ is remaining. Let us check it out. In a Q, alkyl is CH2Br. Yes, sir, this is a primary only. This is fine, sir. Q is okay. Because alkyl should be primary. What is alkyl? RX should be primary. In a P, C6H5CH2Br. Yes, sir, that is also primary. Means benzyl halide. Yes, sir. P and Q is okay, sir. The option is C, sir. Take a screenshot.
Sir, how C6H5CH2Br is primary, sir?
That's called as benzylic halide. Already I told you, no. The halogen attached to sp3 carbon atom are easily replaceable. Whereas in S, it is attached to sp2 carbon atom. It is not possible.
Sir, and more than that, it should be alkoxide, right? But it is aromatic.
Alkoxide, no. Alkoxide, don't worry. Alkoxide can be anything. Primary, it may be secondary, it may be tertiary. Worry about RX. RX should be primary. Don't worry about alkoxide. You worry about alkylate. This alkylate is vinylic halide, sir. What is vinylic? Attached to double bond. sp2 carbon atom. Not easy to replace.
Okay.
Got it?
Yes, sir.
Okay, right. Next one. This I will clear it. Ethanol, when reacts with PCl5, gives A. What is ethanol? C2H5OH. Let us write. This is also previous year only. C2H5OH. So reacts with PCl5. What do you get? You get alkyl C2H5Cl plus POCl3 plus HCl. This is how it happens. So A is ethyl chloride. And then say A reacts with silver nitrate. What is silver nitrate? AgNO2. And AgNO2 is a covalent compound. So the ion exchange will not take place. Nitrogen carries lone pair. So the bond has to be formed through nitrogen. So what will happen? AgCl is removed, minus, you get C2H5NO2, nitroethane it will come. So this is B. What is the option then? So C2H5Cl and C2H5NO2. C is the option. So Take a screenshot. So 0.44 gram of a monohydric alcohol when added to methyl magnesium iodide in ether liberates at STP 112 cm3 of methane. So let us write. Means what? The alcohol. What is alcohol? ROH. Reacts with Grignard reagent means RMGX. It gives you a methane ethers. And how the reaction is there? Look at it. When you take 1 mole, you are getting 1 mole of methane. And 1 mole of methane, you know that always occupies how much space? 22,400 cm3 of space. Any gas you take, 1 mole of any gas. 1 mole means what? It's molecular weight. 1 mole means it's molecular weight. So 1 molecular weight will give you this much. But he says, if I take 0.44 gram, how much I get? I get 112 cm3. Then X is equal to what? 0.44 into 22,400 divided by 112. It gives you what? 88. That means molecular weight of your alcohol is 88. And also he says, your alcohol forms a carbonyl compound. Your alcohol forms a carbonyl compound with PCC. What is carbonyl? Carbonyl means both aldehyde and ketone. Both aldehyde and ketone. And he says with Tolling's reagent, it forms a silver mirror, means Ag precipitate. This is silver mirror, we call it as. And we know that silver mirror is given by not ketone. It is given only by aldehys. Ketones will not give. Then if you have to get aldehyde, the alcohol should be primary alcohol, sir. So this is one clue. So what is primary? If you observe here, E is given. D is secondary. C is also secondary. So C and D cannot be the option. So A and B is the option. And the molecular weight should be 88. That is the one more clue. Both are primary only. This is also primary, this is also primary. Then what is the answer? Who is having molecular weight of 88? So first option is having molecular weight of 88. So A is the answer. Then one more question we take. So reaction towards concentrated HCl.
Excuse me, sir.
Yeah.
So can you repeat the previous question once again?
Here he is asking.
Yes, sir. Miss Purnima, she has doubts, sir.
Yeah, you can ask her to call me, no problem.
Yes, sir.
Here, Purnima, 1 mole of alcohol gives you 1 mole of methane. And remember, Purnima, 1 mole of methane is a gas. Any gas will occupy 22,400 cm3 space. And what is 1 mole, sir? 1 mole means its molecular weight. We don't know that one. But he says 0.44 gram gives you 112 cm3. So this we have to do cross multiplication, Purnima. These two values we have to do cross multiplication. I calculate X. X is nothing but molecular weight. What is the molecular weight? I got 88. Just keep it like that. And he also says your alcohol forms a carbonyl compound that answers Tolling's reagent. This is silver mirror. Silver mirror is given by aldehyde only. And only aldehyde is given by primary alcohol. Because you know that one. Primary alcohol gives you on oxidation aldehyde. Secondary alcohol on oxidation gives you ketone. I don't want ketone, I want aldehyde, then it should be primary. Then C and D is not the primary, they're secondary. So only primary is A and B. And it should be primary also, the molecular weight should be 88. One who is having molecular weight, A is having that molecule. How to calculate? Calculate Purnima. How many oxygen is there? So one oxygen is there. 16. Take that. How many carbon atom? 3, 4, 5 carbon atom. 5 carbon. 5 carbon means Purnima 5 into 12. That is 60. Add it. We have to add all these things. How many hydrogen? Sir, 9. 9, 10, 11, 12. Sir, 12 hydrogen. That means you have to add 12. You have to combine all these things. You get 88. So 88 is the molecular weight of A. Got it? Then coming to this one. What will happen when it reacts with HCl? The first step is removal of OH. The first step is removal of OH. So what will happen when you remove OH? Let us simply take the fourth one. What is pH? Benzene. Benzene. It is like this, no? CH2OH. Let us remove the OH. When I remove the OH, you get positive charge on the carbon. This is called as carbocation. What kind of carbocation? This is benzyl carbocation. This is fourth structure. Like that, you remove this OH. This carbon gets positive. This is a secondary carbocation. Like this, you remove this OH. You get what kind of carbocation? Secondary. This is also secondary. You remove this OH. You get carbocation. Again, this is also secondary. And when it comes to carbocation, I already told you, when I've done alkynes, benzyl carbocation is more stable than tertiary carbocation, more than secondary carbocation, more than primary carbocation, other than CH3. Then CH3. And also remember, electron donating group stabilize carbocation. So electron withdrawing group destabilize carbocation. Which are the electron group? Chlorine, bromine, iodine, nitro groups, CN groups, all these groups, CH4 groups, COH groups, they all destabilize carbocation. And when you say that, fluorine is a withdrawing group. Fluorine is a withdrawing group. So it destabilizes carbocation. So first is less stable, second is also less stable. Who is more stable? Third and fourth. But in third and fourth, third is secondary, four is benzyl. So who is more stable according to our this one? Benzyl is more stable than secondary, sir. So 4 is more than third. Then coming to second and first, who is more stable among first and second? So fluorine is bit away in second option, is 2 carbon atom away. Whereas here, very near in first. So second is more stable, then second is more stable. Then first. 4 is more than 3, 3 is more than 2, 2 is more than 1. What is the option? So C option. Take a screenshot. He has given phenol. And he says you are treating with CCl4 and NaOH. Again, this is a Reimer-Tiemann reaction. So Reimer-Tiemann reaction, what do you get? You get salicylic salicylaldehyde and salicylic acid in this case. You get salicylic acid. Then you treat with zinc dust. Zinc loves oxygen. It removes oxygen in the form of zinc oxide from where? So from the OH. From the OH. So what is remaining? When the O is removed, only H is there, sir. Only H is there. You have COH. Then you are treating with soda lime. When you are treating with soda lime, what is soda lime? Mixture of NaOH and calcium oxide. What they remove? They remove carbon dioxide, means CO2. So when they remove carbon dioxide, what is remaining? Sorry, again, only H is remaining. And that molecule is called as benzene. What is the option? Sir, option is 6. Option is 6. Phenol, paramethyl phenol, metanitrophenol, paranitrophenol follows the order of increasing acidic strength as what will be the option? You have to write the structure. So one is phenol. Phenol is normal molecule. Then paramethyl phenol. Paramethyl phenol is phenol. At para position, you're having a methyl group. Then you're having paranitrophenol, OH group, and paranitrophenol. Then metanitrophenol, this OH and NO2 group. Like this, you're having. Now we have to arrange them in increasing acidic strength. Increasing means from lowest to highest. Lowest to highest. When it comes to acidic nature, already I told you. What I told you? Sir, electron donating group decreases acidic nature. Decrease acidic nature. Which are the donating group? I already told you. CS3, OCS3, OH, NH2. These are all they decrease acidic nature. So electron withdrawing group, they increase acidic nature. They increase acidic nature. Which are withdrawing group? NO2, CN, sir, halogens. These are withdrawing group. They increase acidic nature. So just we have to find out where the acidic nature is present, a withdrawing group is present. Sir, nitro group is there. This is paranitrophenol. And one is meta. Meta means I'll put it in meta position. This is meta position. This is metanitro. This is meta M. So if NO2 group is present, they are acidic. So both are acidic. So both are acidic. Both acidic. But who is stronger? One who is at para is more stronger because meta, the influence is less. The influence is less. Who is less acidic? Sir, where the CH3 group is present, they are less acidic. Because CH3 group is a donating group. So first we have to start with this methyl phenol. So methyl phenol is very less, sir. Is less basic, less acidic. Is less acidic. aromatic like this. Then comes, sir, phenol is less acidic then. Then these both the people are more acidic. But among these two, who is more acidic? Para-nitrophenol is more acidic. Then you should come at last. Para-nitrophenol is more acidic. So then it has to be meta-nitrophenol. So what is the option? Sir, option is C, sir. Option is C. Option is C. Oh, wait. Not option C. Paramethyphenol, then phenol, metanitrophenol, paranitrophenol. Option is B, sir. Option is B. Please take a screenshot. Yeah. What I will do is that I will take to from the amines. I'll just give you a brief idea about organic compounds containing nitrogen. Okay. In this organic compound containing nitrogen, what is important reactions are? Amines can be prepared by 6 methods. From Hoffman degradation, where amide is converted into amine by treating with bromine and KOH. Then you can prepare it by phthalimide by treating with alcoholic KOH, then with RX, then with aqueous KOH. Then you can prepare amines by reduction. Amide undergoes reduction to form amine. Nitrates means cyanide undergoes reduction to form amines. Then alkyl halide, they react with ammonia to form amines. Nitrohydrocarbons, they undergoes reduction to form amines. And again here, very important is basic nature. Amines are basic. Why amines are basic? Because they have a lone pair of electron on the nitrogen. And we call it as a Lewis base. Who is a Lewis base? Anybody who donate a pair of electron. Who donate pair of electron, we call it as a Lewis base. In a gaseous phase, tertiary amine is more than secondary and primary and ammonia. Whereas in aqueous phase, secondary is more than primary, tertiary and ammonia. Remember this. And always here electron donating groups, they increase basic nature. So they increase basic nature. And electron withdrawing group, so they decrease basic nature. They decrease basic nature. And here, what is important reactions are carbolamine reaction. What is carbolamine reaction? Where amines reacts with chloroform. Where amine reacts with chloroform, CaCl3 and KOH to form a isocyanate, which gives a bad smell. But this is given by only those amines which are primary in nature. Next reactions are reaction with nitrous acid. Primary aliphatic amine react to form alcohol plus nitrogen, whereas primary aromatic gives you diazonium salts. So secondary amine gives you yellow oily layer, and tertiary amine, it forms a salt, so colorless liquid. Then important reaction is Innsberg reagent. What is Innsberg? Sir, benzene sulfonyl chloride. Primary amine reacts with benzene sulfonyl chloride to form a salt, which is soluble in NaOH, homogeneous. Secondary gives you a salt which is insoluble in NaOH. And tertiary amine, clear solution. Please remember this one, very, very important. Then what is very important is one more subtopic in this one. I will take a board and I'll explain to you what the subtopics are. Diazonium salt, we call this. What are the things we have to remember in diazonium salts? Only one preparation is there. From aniline. So from aniline, one preparation is there by treating with Na, NO2 and HCl. This will react to form HNO2, nitrous acid. And this reaction we have to carry it out at 0 degrees Celsius because the diazonium salts are stable only at a cold condition. And there are two kinds of reactions, which are those? So one type of a reaction is called as a retention of azo group. Retention of azo group. What is the azo group? In that benzene diazonium chloride, no? We write di, no? N2Cl. This N2 is called as diazonium group. These are also called as coupling reaction. These are also called as a coupling reaction. First one with aniline. It reacts with aniline to form yellow precipitate. With phenol, so with phenol it forms a diazonium salts. With phenol it forms a azo dye, we call it as that. It is an orange color precipitate. In both the cases, it forms azo dye only, a colored precipitate. Dye is a coloring pigment used for clothing. Another reaction is, this is retention of azo group. Now we are breaking the azo group. That is called as cleaving of azo group. Cleaving of azo group. What are the reaction? You already studied Sandmeyer's reaction. So what is Sandmeyer's reaction? Where benzene diazonium chloride is treated with copper chloride and HCl to form what? Chlorobenzene. Then we are having Gutterman reaction. We are having Skyman reaction. Then a benzene diazonium chloride can be converted into what? Phenol by heating with water. By heating with water, sir. Then benzene diazonium chloride, so is converted into iodobenzene by treating with Ki. Or one more reaction where benzene diazonium chloride is converted into benzene. We call it as deamination by treating with H3PO2, phosphorus acid. Okay. In all this reaction, we are removing N2. That's what is called as cleaving of azo group. Cleaving of azo group. So this much you have to remember in a theoretical aspect of these particular nitrogen compounds. Then we can go to some questions. Which of the following reaction? Which of the following reaction is appropriate for converting acetamide to methanamide? Acetamide to methanamide. What is acetamide? Sir, CH3CONH2. CH3CONH2 is converted into methanamine. What is methanamine? Sir, CH3NH2. So there's only two ways. Either by reduction you can do it. Either by treating with bromine and KOH you can do it. So reduction is not given anywhere. He has given Stephen's reduction, but Stephen's reduction is to get aldehyde to hydrocarbon. Aldehyde to hydrocarbon. So this cannot be answered. Carbolamine is all about getting cyanide. So that is also not the answer. So only A and C. But in A, C, we don't use amide only. So C cannot be option. Only option is where we treat amide with bromine and KOH to get amides. Next one. Which of the following amines will give the carbolamine test? Which of the following amines will give the carbolamine test? What is carbolamine? Already I told you, formation of isocyanide. I told you, it is given by only primary amine. What is primary amine? Amine having general formula RNH2. Just you have to find out where the NH2 is present. So only option A. That will give you carbolamine. Very simple. These are the questions which appeared in medical examinations. Easily you can clear it. And the same kind of question will come in CET also. There is no rule that, oh, it does come in medical exam, so they will not ask in CET. There is no rules like that. So the correct order of basic strength of methyl substituted amines in aqueous solution. I already told you, in aqueous, the basic nature, when you take secondary amine, is more basic than primary, which is more basic than tertiary, which is more basic than ammonia. So your option should start with secondary. Let us check it out one by one. A, no sir, this is primary. C, it starts with tertiary, cannot be. A cannot be, C cannot be. Then, sir, D, it also starts with tertiary, cannot be, sir. B, yes, sir, it starts with secondary. Let us check it out. Secondary, then, yes, sir, primary, then tertiary. Yes, sir, this is right. This is right. Option is B, sir. These all appeared in last few years in medical examinations. And same kind of questions will appear in CET also, my dear students. And I told you, basic nature of amine is very important. So the amine that react with Innsbruck reagent to give an alkali insoluble product. What is Innsbruck reagent? I already told you. Benzene sulfonyl chloride, which reacts with with your amine. If it is your primary amine, I told you, it forms a salt which is soluble in base, soluble in alkali. Alkali means NaOH. Whereas if it is a secondary amine, it also forms a salt, sulfonylamides, but they are insoluble in alkali. But they are insoluble in alkali. Which is the secondary amine? I already told you. Primary amine means RNH2. Secondary amine means RNHR. Tertiary means there is no hydrogen, only R group will be there. So we have to look for NH group. Where the NH group is present? Sir, yes, sir, in A. Everywhere N is there. N means tertiary. So NH2 means primary. Sir, NH2 means primary. So where the NH is there? Sir, in option A, sir, it is a secondary amine. That is the option. So, take a screenshot. Next. So nitration of aniline in a strongly acidic medium also gives metanitrile. Why? Usually, when you take aniline, when you subject it to ESR reaction, what is ESR? Electrophilic substitution reaction. It may be chlorination, bromination, nitration, sulfonation, what it may be. You are going to get ortho and para. Why, sir? We say NH2 is an activating group. Any activating group on benzene will always gives you ortho and para. Then he is asking if the same aniline, if undergoes nitration. What is nitration? Treating with nitric acid and sulfuric acid. nitric acid and sulfuric acid. That is addition of NO2 group is called as nitration. Electrophile is NO2 plus. You are supposed to get ortho and para, but he says you get meta also. Why? Then you have to say sum of the aniline means few molecules. What will happen? They undergo protonation because HNO3 is acid. Sir, HNO3 is acid. And acid gives you H plus. By using this H plus, they undergo protonation. When they go protonation, they form a molecule called as NH3 plus. And this is called as anilinium ion. And this anilinium ion is metadirecting. Why? So it's a deactivating group. So only during nitration, in addition to ortho and para, sir, we also get meta. Why? Remember this protonation and formation of anilinium. Where is that word is present in our given compound, given question? Check it out. Where it is present? Sir, you can see in the type anilinium ion. Yes, sir, that will be the answer. D is the answers. Take a screenshot. So correct increasing order of basic structure. Already told you. Increasing order means lowest to highest. And in amines, I already told you. Electron donating group. Increase basic nature. They increase the basic nature. So electron donating group increases basic nature. Whereas electron donating group means what? I told you. Donating group means CH3, OCH3, NH2, OH. Electron withdrawing group means they decrease basic nature. Which are the withdrawing groups? I told you NO2, halogens, cyanide, all these things. So they decrease the basic nature. Where it is there, NO2 is there, sir. Yeah. So here the basic nature will decrease. So this is the first option. So second is the lowest. Then CH3, so it's a donating group. So here it will increase. Basic nature will increase. So third is highest. So in between will come, then first will come, sir. So second, one, third, sir. That is the option. Where it is present, sir, option C, sir. Please take a screenshot. So the correct statement regarding the basicity of aryl amine is basicity of aryl amine. What is aryl amine? Say CH3NH2 is a alkylamine. Is a alkylamine. And alkylamine is more basic than aryl amine. Aryl amine. And in RLMN, it is less basic. Why? Because of benzene ring, there is a delocalization. Delocalization means it removes the electron from the nitrogen atom. There's a delocalization of pi electron. And this delocalization will remove the electron present on the nitrogen. So electron density on nitrogen decreases. So basic nature also decreases. But he says R elements are more basic. Wrong, sir. Again, he says R elements are more basic. Wrong, sir. And R elements are less basic. Yes, less basic than alkylamines. This is the option. Let us take. R elements are more basic than alkylamine. Again, it is wrong, sir. Again, it is wrong. What is the option? Sir, option C, sir. Option C. A given nitrogen containing aromatic compound A reacts with tin and HCl followed by HNO to give unstable compound B. B on treatment with phenol forms a beautifully colored compound C with a molecular formula C12H10N2O. The structure of A is.
Sir, just a minute, sir. Hello.
Yeah, tell me.
Yes, sir, just a minute, sir. Students, please don't leave the session after the class ends, because I'll share the schedule for the last week. So please be in the session. Don't leave the session.
And
Yes.
Anikesh,
Yes, sir.
Anikesh, when you announce it in last schedule, replace all the biology class, no?
Yeah,
All
by
the biology
Pawan Nag, sir.
by Pavan, yeah.
Yes, sir.
A given nitrogen containing aromatic compound A reacts with tin and HCl followed by HNO2 to give unstable compound B. B on treatment with phenol forms a beautifully compound C with a molecular formula C12H10N2O. The structure of a compound A is. Say he says A reacts with tin and HCl. That means reduction. It is a reduction, sir. Then he says followed by HNO2. Say we get some substance here. So let us take it as simply, let's keep it as P. You get treat with HNO2 and you give a B. And B on treatment with phenol. E says forms a colored compound. Colored compound means azodide. Azodide can be formed only when phenol reacts with diazonium compound. If diazonium compound is required, P should be aniline. P should be aniline. What is aniline? Benzene with NH2. Then A should have a benzene. Definitely should have a N. And it's a reduction. Reduction means what? Removal of oxygen or addition of hydrogen. Then they should have a oxygen. So A should be, sir, nitrobenzene. B should be nitrobenzene. That is option B. Because diazonium salts are formed only by aniline. And diazonium salt react with phenol to form azodide. These are colored substances. In this case, what color? It's an orange color dye. And aniline can be obtained only by reduction. Then the compound should be nitrobenzene on the side. Innsbruck reagent is. Look at it. This is a last year question. CET. Innsbruck reagent is a benzene sulfonyl chloride. Very simple question. Again, from last year. He is asking what is the final product R. What you are doing? You are adding a bromine. And electrophile is Br plus. Electrophile is Br plus. That means an NO2 is a deactivating group. You know that already I told you. If it is a deactivating group, the product should be meta. So the P should be meta-nitrobenzene. Meta means 3 position. Meta-bromo-nitrobenzene. Sir, this undergoes reduction, he says. Tin and HCl means what? Reduction. I told you. What is reduction? Removal of oxygen. When you remove the oxygen, what do you get? NH2. So Q is aniline, sir. And then you treat with NaO2. That is called as diazotization. Diazotization. What do you get? So instead of NH2, there you get what? N2Cl. You get diazonium chloride. And all the everywhere you are having Br. Br. Then what you do? So you treat with water and warm it. When you treat with water and warm it, I told you, the N2Cl will be replaced by OH. And you get Br. OH is a function group. So one position, second position, bromine should have a 3 position. What should be the option? So this is the A. Why? OH is 1. 2. Benzene is at 3rd position. A is the option. You can take a screenshot if you want. This all appeared in your CET question paper. Which of the following is the lowest boiling point? So how to make it? Already I told you, boiling point depends on number of force of attraction. Means bond. More the bond, more the boiling point. Sir, in carboxylic acid, you'll be having 2 hydrogen bond. Alcohol, you are having 1 hydrogen bond. Sir, amine, yes, they're also having hydrogen bond. But in ether, sir, there is no hydrogen bond. So here force of attraction is less. And boiling point is also less. So option is these are ethers. If aniline is treated with 1:1 mixture of concentrated HNO3 and concentrated sulfuric acid, para-nitroaniline and meta-nitroaniline are formed nearly in equal amount. This is due to already I told you. This I already answered. If you take aniline, NH2 is the activating group, I told you. So if you do nitration, what is nitration? Addition of NO2 plus. You get only ortho and para. But he says meta is also obtained. Why? I told you, some of the aniline undergoes protonation. Protonation to form NH3 plus. And this is an anilinium ion. Once it becomes anilinium ion, you get meta. Because NH3 plus is a deactivating group. So in case of nitration, you get both ortho and para and meta. So look for this word, protonation and anilinium ion. Where is present? Yes, sir. In second option, there is a given, sir. So which of the following is least soluble in water at 298 Kelvin? At 298 Kelvin. What is least soluble? Very simple. Base is soluble in acid. Base is soluble in acid. So he's asking least soluble. That means lesser the basic, less soluble. Lesser the basic, less soluble. And in this case, this is a primary amine, this is a tertiary amine, this is a secondary amine, this is a aryl amine. And among all these things, we know that what is aryl amine? It's nothing but aniline. Already I told you. In aniline, what will happen? So delocalization takes place in a benzene ring. Because of delocalization, the electron present in the nitrogen is taken away. So the basic nature decreases. Basic nature decreases. So this is less basic and this is less soluble. D is the answer. This appeared in 2019 CET. Which of the following will be more stable diazonium salts? I already told you. Aliphatic diazonium salts are less stable. Less stable at all temperature. At all temperature. Only aromatic diazonium salts means aromatic means benzene should be. Aromatic diazonium salts are a bit more stable. More stable at that is also cold condition. Which is aromatic? So this is aliphatic. Aliphatic, so cannot be. So only option with the aromatic diazonium salt is B, sir. B is the option. Anikesh?
Yes, sir.
Can you stop here?
Yeah, yes, sir. We can, sir. It's
Yeah,
already
right.
time up.
My dear
So,
students, we have covered both organic compound containing oxygen, that is alcohol, phenol, ether, as well as we have also covered organic compound containing nitrogen, that is amines and diazonium salt. Please, I'll be sending the file also. Download it and practice. If you have any doubts, please send mail to us. We will address it. Anikesh, thank you.
yes, sir. Thank you so much, sir.
Okay.
Students, I hope the okay. Someone, sir, student wants to ask something.
Yeah, tell me,
Yep.
tell me.
Sir, can you please conduct some extra sessions sir, on organic?
Yeah, I will also. This question paper only is having extra questions. Please solve it. If you're not able to solve, please send a mail to me. I will send you the answer. Okay.
No, sir. He is actually asking like if we can conduct any like more classes after June 10th also.
June 10th
Yes,
also.
sir.
Let us
Like
see. Yeah, I
evening
just have to.
classes.
I have to speak to the seniors. If they give permission, we can do it.
Yeah, so that's what.
Yeah.
Thank you, sir.
Okay.
Yeah. So students, I'll be sharing the slide now. Please take screenshot for uh, the week 3 schedules. Okay. Give Please be in the session. Don't leave the session. Hope students you took the screenshot, right?